Chantel saved wages from her summer job to purchase a used car with 45,817 and 2/10 miles on its odometer. She generally fills up when her car has approximately 1/4 of a tank of gasoline left. Chantel keeps track of the odometer reading after each fill up in a table to calculate her gas mileage. Use finite differences to generate a function model for the odometer reading in terms of the number of times Chantel has filled up the car with gasoline. Then compare the domain and range of the function model to the domain and range of the dataset. Okay, so let's go ahead and use the finite differences to find our function model. So we'll take for our y values on top, we'll take the last, and then we'll subtract the first, and then on our denominator we'll divide by the last x value minus the first x value. Okay, typing in the numerator, I get 2,502, and then we know 7 minus 0 is 7, and then dividing those, we get 357 and a pretty long decimal. Let's go ahead and just round it to the thousands. So it's 420, and then there's an 8 and then a 5. So that's going to become a 9 if we round that there. And so that's going to be our rate in our function. So our function, we'll just call that r of x, our odometer reading, and x will be the number of fill-ups. So r of x equals 357 and 429 thousandths x, and then plus the y-intercept. And so when x is 0, then we see that our y-intercept there is 45,817 and 2/10, which is also our first y value there. And so there's our function. And so now let's compare the domain and range of our function model to the domain and range of the real situation in the problem. Let's go ahead and use a table to organize our domain and range for each the function model and the data set. And so for r of x, our function model, this is a linear function. And so linear, we have any number that we can put in for x, there's no restriction there. Any number can come out for y, there's no restriction because there's no square roots, no fractions, nothing that can interrupt that. And so we are going to have all real numbers for both our domain and range. In set builder notation, that would be the set of x's, such that x is in the real number set. And then the range would be the set of r of x, such that r of x is in the real number set. And then for our data set, we have a very specific subset of numbers here. And so notice for our x values, these are actually all whole numbers, and they're only between 0 and 7. And so we could just write that, well, that's the set of x's, such that x, and then since they're all whole numbers, we can say they're in the whole number set, and then only between 0 and 7. So you can write 0 is less than or equal to x is less than or equal to 7. And then our range is very specific as well. But these are actually rational numbers, and so we'll just need to list out these numbers specifically. So we're just going to go ahead and write it out as a set of r of x, such that r of x, and then we can just write exactly what they're equal to there, each specific point. Okay, it's not the most neat, but it's just a set of r of x, such that r of x is equal to every single value we have there for our odometer readings in the table. And so that pretty much covers it. Just notice that our function model would be very inaccurate if you didn't consider the domain of the actual data set, because the function model includes every single number, negative, positive, decimal, every single number in the real number set. And so that's really important to realize that there are some definite restrictions here. And so let's go ahead and summarize our answer. Let x represent the number of fill-ups and r of x represent the odometer reading of Chantel's car. R of x equals 357 and 429 thousandths x plus 45,817 and 2/10. Then we have our table with our domain range for our function model and data set. Since r of x is a linear function, both its domain and range contain all real numbers. The data set, however, has domain that is a specific subset of whole numbers and a range that is a specific subset of rational numbers. Infinitely more data points are contained in the domain and range of the function model r of x than in the finite data set.